Today our lecture is about risk identification. In the last lecture, we discussed the risk assessment process. And I told you guys that risk assessment process starts with risk identification, risk analysis, and then risk evaluation. All right. So let's look at what's risk identification all about. Now, so firstly, like I said, when we discuss the difference between hazard analysis and risk assessment, firstly, hazard, as we said, is anything that has the potential to cause harm. All right. While risk is the likelihood for harm to be caused. So the fact that something has potential to cause harm does not necessarily mean that there's a likelihood that this harm is going to happen. So risk assessment is a further step from hazard analysis. Hazard analysis simply means identifying hazards and determine the consequences of those hazards, which means that what are the sources of harm and what are the consequences or the severity of the impact of the harm. All right. While risk assessment now goes further to discuss the possibility that that will happen. Okay, the probability that it will occur or the likelihood that it will occur. This likelihood is exactly what characterizes risk assessment. All right. So when you say hazard analysis, it's different from risk assessment because in hazard analysis, you're simply talking about potential hazards and their consequences. All right. While in risk assessment, we're talking about the likelihood and possibilities of those unwanted scenarios happening. So here we say that the fact that a hazard exists does not necessarily mean that a risk is produced. So if there's a hazard, well, the likelihood may be zero, right, or close to zero, right? Now, risks are derived or produced from hazards when their exposures to people or assets pose a chance. This is the key word here. There's a chance or likelihood for loss. Now, for risk to exist, the exposure to a hazard must pose a severity of loss or harm. Now, the severity here is characteristic of the hazard, and the likelihood of occurring here is characteristic of the risk. So if no person or no asset is exposed to the hazard, then there is no risk. All right. So you can see, like when we discussed about the fish in the water, if nobody goes into the water to swim, then there's no risk. But the fact that it is there, it's a potential hazard. All right. Now, the chance for loss or risk is measured by the likelihood. Okay, so likelihood is the characteristic of risk. Is the likelihood of the event occurring and the resulting severity or consequence of the loss. All right. Now, in hazard analysis, you can see here that it identifies the hazards and the exposures and the range of severities. So sometimes your work could stop here. You could just simply identify hazards and exposures, what are the range of severities, right? And see if there are some controls that could be put in place to prevent any risk, okay, to prevent any exposure, for example, as we said, to prevent the exposure of workers or people to those hazards. Or you could go further to identify, analyze how the event could occur and its likelihood of occurrence. So in this case, when you determine the likelihood, you could know what risks are most likely to occur and what are those that are less likely to occur. In estimating the risk level, you could use this formula, which is basically the severity multiplied by the likelihood. And there could be other formulas as well. Now let's look at this as well. If you look at this diagram, we have firstly establishing the purpose and scope, as we discussed previously. So you establish purpose and scope of your risk assessment or the hazard analysis. Next, you identify the hazards, all right? It could also be failure modes, if it has to do with equipment, for example, or some systems, all right, where you could identify possible failures. So you identify failure modes. Next, you identify current controls. Remember last time we
Yes,
discussed, uh, yes?
The slide does not change.
Okay. Can you see the slides now?
No.
What about now?
It's good now, teacher. It's clear.
Yes.
All right. So next you identify current controls. Okay. It means existing controls. And then you analyze frequency and duration. Okay. Frequency and duration of the hazards. And lastly, analyze the severity of the hazards. Next, you analyze the likelihood. There's a likelihood that this is possible, that this will likely occur. And this helps you to define the risk based on the calculation we stated earlier. Then you prioritize the risk, which means you rank them, okay, according to their risk scores. Now, with this residual risk, you have to determine if it is what's acceptable. What a residual risk means after you've applied the current controls, the existing controls. After you've used the existing controls, you determine the residual risk. If this is acceptable, then you document. It is not acceptable, then you select implement additional controls, and then you go back to identifying the hazards, all right? Or at least you go back to analyzing this. At least you can go back to analyzing this, or analyzing the likelihood, or even the severity, okay? Once you've implemented additional controls. And this may modify the risks, okay? And then at that point, the residual risk might be acceptable. All right. So you can see the difference between the hazard analysis phase and the risk assessment phase. So hazard and risk identification involves finding. That's the first thing you have to do. You have to first of all search for various types of hazards. You have to anticipate some of them, recognize, and describe them. All hazards that could affect the achievement of an organization's objectives. Okay, we keep using the word objectives here because this is a more general term for risk assessment. All right. Now, hazard identification can be used as a standalone technique or as an initial step in more detailed risk assessment methodologies. For me, what I like to do is I like to start with hazard identification, and then based on that, I can decide on which of those hazards should be carried further to risk assessment. So you probably will not do risk assessment for all hazards that have been identified, but you have to select some of those hazards which you feel, or based on your analysis or historical data, are the most contributing hazards to losses, to business losses or other losses in the organization. Then you carry that over to risk assessment. Now, the process of hazard analysis identification, first of all, is identify hazards, exposures, and failure modes. How could people be exposed to these hazards? What are the ways, failure modes that could occur? Causes and triggers. What could trigger these hazards? Okay. Controls that are available in place, and then the consequences of these hazards. All right. So this is one particular process of a hazard analysis. So let's start with the first process, which is identifying the hazards. Now, identification of hazards is one of the most important steps in risk assessment because basically it all has to do with what kind of hazards are present in the workplace. And this is very, very crucial because Once you miss any key hazard or any important hazard, then this may jeopardize your risk assessment effort. All right. So if hazard, the source of risk, are not recognized and identified, risk cannot be assessed, reduced, and managed. Now, the identification of existing and potential hazards within the context of the assessment should be performed. In addition to listing these hazards, a description or characterization of the hazard should be included. So once you list the hazards, also you want to also define them or characterize them, which means you describe them. Now, there are many references and resources for common categories of hazards. OSHA has a job hazard analysis. You can find it at this link, okay? We also have other categorization, like here, OSHA Academy, which is an online training platform. They have this categorization called MIPS, materials, environment, equipment, people, and systems. All right. So you could identify hazards that have to do with materials, hazmat, toxic, flammable, explosive materials, things like that. You may want to identify hazards that have to do with the environment or the equipment, hazards having to do with people or the system. The system in the organization itself may lead to may cause things to go wrong. Also, you could use this system, which I have listed here, firstly by identifying the accidents and then the causes of those accidents as the hazards, all right, as the sources. So this is the unwanted scenario, which is the accidents, okay? All these are unwanted scenarios. So all these are unwanted scenarios. And they're all accidents. I mean, crane and lifting equipment accidents, slip, trips, and fall accidents, power tool accidents, you know, and things like that. So what could be the causes of this? This can be identified as a hazard or the cause sources of risk, which are the hazard. The causes of these could be identified as hazards. Okay. So basically, we have crane, lifts, slip, trips, and falls, electrical heat, chemical bonds, power tools, falls from height, falling object. You can say all the way down to drowning. What could lead to what could cause any of these to be described as hazards in the workplace or categorized as hazards in the workplace? Something else is for you to identify the tasks. You can determine what tasks you have. For example, a job. Just like you do job hazard analysis, you have the various tasks that you could have in that work, and each of those tasks could have potential hazards. Okay, each of those tasks will have potential hazards, and then you could have things that could go wrong or could lead to accidents. All those ones hazards. So here you can see this is another categorization which is used by the NEBOSH. You have, for example, noise hazard categories: noise, vibration, radiation, mental ill health, violence at the workplace, substance abuse at work. You have ergonomics, work-related upper limb disorders, manual handling, load handling equipment, hazardous substances, health, work environment, welfare, working at height, confined spaces, lone walking, slip, trips and falls, movements of people and vehicles, work-related driving, working equipment and machinery, fire, electricity. So you can see you could use all this together. You don't have to use just one of them. You could use all these together and then come up with a comprehensive list of the hazards in the workplace, or a comprehensive list of hazards that you're interested in. Okay, so basically there are other checklists as well that you could use. Okay, you may be able to find some other materials from standards, guidelines, manuals, you know, and you can use all this to identify all possible hazards inherent or characteristic of your workplace. So now let's identify what we call the exposure and failure modes. Now you know the hazard, but because you have a hazard, does not necessarily mean there's a risk. You have to first of all establish how this hazard could be, how people or facilities, right, could be exposed to these hazards. So one thing is to identify the exposures to the hazards as well as failure modes of equipment or facilities or systems. So like we said, the existence of a hazard alone does not necessarily translate to a risk. So risk is derived from the exposure to the hazard. So in addition to identifying the hazards, its potential exposure to people, property, or assets, and the environment, or other things of value must be identified. And there are different ways which people or facilities could be exposed to hazards. One way is direct contact with a hazard, like touching, okay? Indirect contact with the hazard, okay? Or proximity to the hazard, duration of exposure, that's the time, usually in terms of noise. Okay. Magnitude of exposure, quantity, okay? For example, when you talk about H2S, concentration or dose of exposure, all right? So you can see different routes of exposures to the body now, all right? One is inhalation, like smelling the hazard, inhaling the hazard, or gases, okay? Ingestion, when it comes into your system from the mouth, the nose, the eyes, okay? The mouth and the nose, okay? The mouth. Sorry, ingestion is the mouth. Inhalation is the nose. Absorption could be from the eyes, okay? Eyes, and then you could have injection, could be through the skin, okay, or through any piercings when somebody gets injected, like you can see from the needle. All right. So these ways people could get into direct contact with, get into contact or get exposed to hazards. As for failure modes, this refers to state or conditions where a system fails. Okay, that's why I call it modes. So it's basically modes of failure, right? So what is the mode of failure of the system? How can the system fail to perform as it is expected? Or how it deviates away from its original design or its design tolerances. And this could result in harm or a potential hazardous event. So we call this failure mode. It could be failure mode of a system or an asset and equipment. So examples of these failure modes, for example, be a premature operation when you do not expect the equipment to start and then it starts. Okay. Failure to start, okay, when you try to start it, then it doesn't start. Okay. Failure to stop operation, okay, like the failed when the brake fails. Failure during operation, local exhaust system fails during welding, degraded or deterioration of the operation, leak or in containment vessel, okay, loss of containment, exceeded capability / capacity of the operation, that's overpressurization of a vessel, okay, reasonably foreseeable uses and misuses of operation, for example, using forklift to raise worker to reach components. So there could be various failure modes, all right? Some of these could be documented in the manuals of the equipment, okay? Some of them can be listed in standards or guidelines. Some of them could be listed, you could find some of these failure modes as well in past accident records, or be derived from the experience of workers that have direct contact with those operations. Okay, workers that are experienced in those operations could also give you information on the various failure modes. Next is that you identify the causes and triggers of those hazards. All right, so it's very important to understand under what circumstances, conditions, or actions or inactions that exposure to the hazard will be caused. So now hazards can be acute in nature. Acute means it occurs immediately. The effects are felt immediately, immediate harm from single exposure. We could have cumulative type hazards, which develop from prolonged or repeated exposure, and we call this word chronic. All right. We call this one chronic. Now, basic causes may include, that is causes or triggers of those hazards, machinery design, okay, poor design, selection, poor condition, or poor use when it's not used in the proper way, like the forklift, not used for the right thing, poor maintenance of the equipment. It could come from actions or inactions of humans, like for example, unsafe actions, unsafe acts, knowledge, lack of knowledge and training, lack of skill, capability, inattention, interaction and communication, distraction. To come from management, the system in the organization, management system, where you have poor direction and supervision, lack of enforcement of safety rules and regulations, poor communication between management and the shop floor operations. Methods, okay, they come from the methods used in design, methods used for the system, processes, procedure, task, consistency. So causes of triggers of hazards become from the methods used, okay? Materials as well, the kinds of materials used, from the elements and constituents of those materials, okay? It could be hazardous due to that. The selection of the material, because safer materials or less hazardous materials could be selected. Handling of those materials, lack of proper handling or storage, use, and disposal of those materials may be the triggers of hazards. Environment, design and layout of the environment, the design of the for example, of a factory, of the plant, and things like that. The condition, this could be the environmental condition, right? External factors as well. All this could be triggers for hazard. Now, in hazard identification, there are various tools that could be used. You can see there's a huge list here, from brainstorming to cause and effect analysis, syndical analysis, checklist, Delphi technique, design safety review, FMEA, hazard, historical data analysis. So you could see job hazard analysis, preliminary hazard analysis, structured interviews, toxicity assessment. So there are various techniques to identify risks, okay, in the workplace, or hazards in the workplace. All these are examples of techniques that could be used. So discussing each of these techniques one after the other is going to be a separate thing entirely. In this course, we only aim to just explain some of them, all right, not all of them. Not all of them are so common, actually, because it depends how you select what hazard method to use is a separate topic on its own. So this is an example of a JHA. You can call it a JHA, which is called Job Hazard Analysis, okay? JHA, or JSA, which is Job Safety Analysis, okay? JSA, Job Safety Analysis. Now, as for the hazard, you can see this for hazard about diesel manufacturing, methanol tank storage. First, you identify the hazard, the cause of the hazard, and then the consequences of the hazard, all right? If you're going to go further to risk assessment, then you're going to have to identify their likelihood. Okay. Identifying the likelihood further will take you to the risk. So here you can see it lists various hazards, okay, for the biodiesel manufacturing process, for the storage, tank storage. What are the various things that could go wrong? Okay, thermal expansion of the storage, corrosion of the storage, human factors or errors like overfilling, environmental conditions like carbon steel tanks corroding. This one is corrosion, but for the tanks, trimming and piping, ignition sources. You can see this could be bonding and grounding or static discharge. That's what could lead to this: inadequate conductivity in bonding and grounding, storage system not designed for seismic activity, for natural disasters, proximity to ocean and salts, this is for corrosion, distraction and miscalculation, that's inattention. It could also be to lack of knowledge, lack of experience, lack of skill, lack of capability, incompatible tank and trim materials, all right? That is the very thin tank material, not having enough thickness, all right? And we could have faulty blocked vent, excessive in-tank vapor generation. This could lead to thermal expansion. And what are the consequences of this? This could be overpressurization, could lead to loss of containment, property and tank damage, loss of containment, methanol product loss, same. Damage to equipment from fire and explosion because of the ignition sources. So you can see these are various consequences of this hazard, all right? So you could sit together and with your teammates to develop this hazard list, identify all the consequences from previous accidents or from your experience and from knowledge, and brainstorming as well. So if you're going to do a hazard, first of all, the node means the point where you want to carry out the hazard for. All right, it could be a point in the system. Right, use guide words to identify the hazards. Okay, especially this might be used in a hazard process. Or if you have extra of this, you don't have this, you have too much of this, or you don't have that, you get. So this is one of the ways you could do that. So if you use the guides, you could determine if hazards are possible. If yes, brainstorm on the causes and the consequences. So not only brainstorm, you can also research. Okay, you can research, especially from previous occurrences. All right, previous occurrences, research papers that other people have written. This could give you information on this, and this could also guide you in your brainstorming process. Identify controls. What are the potential controls you can use? All right, and then you call the hazard. Okay, this without discussing the likelihood. Okay, without discussing the likelihood, prioritization of the risk, and also determining the effectiveness of the controls, and determine the current state of the risk, and trying to implement future controls to bring down the risk to the ALAP region, and then determining if it is tolerable, acceptable by the risk owners, and so on and so forth. So it doesn't involve that. Okay, that is not involved. It simply stops at identifying the consequences, recommending some controls. Okay, especially here to reduce the exposure, and record the hazard. Now, the most common hazard-based analysis technique is JHA and GSA, as we've discussed. Okay, this is the most common form, like I showed you in the previous example. So job hazard analysis is a simple hazard analysis tool that is used to help stakeholders identify, analyze, and manage existing and potential hazards, the tasks that they perform. So before you perform any task, it's very important to at least carry out a job safety or job hazard analysis, at least. Okay, if you're not going to do a risk assessment, at least you carry out a job safety and job hazard analysis. And you may have standard checklists for this. Okay, you may have standard checklists for this. So these methods are often used to review job tasks and identify hazards that may have been overlooked in design or redesign phase of the machinery, equipment, tools, workstation, and work processes. All right. So this is another example of a job hazard analysis here. You can see the first step is to determine the tasks that will be carried out, sequence of basic job steps. For example, tank manway opened and gamma jet placed into the tank, that is here. Cause, thick mix and wash. Okay, next is mixing. The next step is rinse with hot water. So what could happen from the first phase? What are potential hazards? Lifting this attached to the hose from the mixer tank. Placing gamma tank in manway position, twisting, tripping over hose or twisting ankle, stepping on the hose. These are examples of things that could go wrong. And you could have you may list other potential hazards. And what are recommended procedures for this? Clear area in front of the manway to allow you to effectively carry the cover or the lift hose. Place portable mix tank to side to allow unobstructed access to the manway. Keep hoses out of the working area. Position body close to the tank manway. Also the position of the person so that it doesn't trip or it doesn't fall. Lift with body hand. Later on, I'm going to share with you a video that shows two people trying to lift an object within a work scenario, and where an accident occurred. I'm going to show you a video so you could see an example of this. So next, you move feet, avoid twisting, use high pressure holes, inspected holes and connections prior to setup. Next to here, you could see that chemical dust could be one of the hazards. Splashing chemical mix, okay, spray from the gamma jet. And how can you control this? Use proper PPEs, such as gloves, glasses, chemical resistant gloves, Mix slowly into the tank to avoid splashing. Okay, so you mix gradually to avoid any amount of it splashing. Close manually and large. Now this is born from hot water, when you have hot water, because you have, yeah, spray from the gamma jet. So control temperature on hot water, close manually and large. So these are examples of this. Of course, when you do a job hazard analysis, it will require you to at least understand what the job is all about, or consult the person that is going to perform this job or this task. He's going to tell you what are the sequences and the basic steps to be followed to achieve this job. And together with this, the guy doing the job, you sit with him together to identify what things could go wrong that could lead to hazards. Okay, this could also be achieved by asking probing questions, things that could generate ideas. So once you list that, then you also list recommended controls and procedures. All right, so you don't have to be an expert at everything to know every single job and the task of sequences and potential hazards and all that, especially since many of them will contain technical terms and terminologies and processes. What is required for you to at least you should be able to ask the right questions. All right, you should be able to ask the right questions from the persons performing these tasks and develop a hazard analysis or job safety analysis together with them. So these are an empty checklist, okay, that you could use for an exercise to identify the job task, the hazards, severity of those hazards, people that may be at risk, and existing controls. So let's look at this now. We could look at, sometimes some of these pictures may be exaggerated, but this in general will give you an idea of what the whole concept of job hazard analysis is all about, or hazard identification is all about. So you can see in this image, for example, this guy is doing unsafe acts, okay, unsafe acts, not carrying out the job in the proper way or using the proper access equipment, and there could be a lot of hazards could result from this. You can see, yeah.
Mr. Can you go back to this page? In the next picture, what's the problem they do?
In which one? Which one of them?
The second one. The second picture.
Yeah, in the second picture, actually, when you use a ladder, it is required to have 3 points of contact. Now, even without even doing that, look at this person here. Don't you think he could fall down? Does it look stable?
No.
Yeah. So that means it's wrong. Sometimes also you can use your common sense. Once you see that this doesn't look right, then it probably doesn't look right. All right, this person doesn't look stable. You could see the way he's standing.
Okay, all right. Because teacher, I saw a lot of when I go, for example, in the supermarket, a lot of workers doing like this same problem, unsafe.
Well, this is wrong. For example, if you want to bring things down, you have to use proper access equipment. All right, you have to use proper access equipment. And if you must use a ladder, then you must have at least 3 points of contact. You must have 3 points of contact on the ladder. 1, 2, 3. Okay.
Okay.
So here he's using, and moreover, this is probably he's using the wrong access equipment. That's probably the case here. He's using the wrong access equipment to bring down this this material. You could probably use a manscape or something. Here you can see all trying to use, this is wrong use of equipment, trying to use this one to lift this one, lift another equipment to this height. Okay, you can see all these guys here. Firstly, they are not using no harnesses, they're not using the harness to be connected to a fixed point. And this is also playing, they are playing on sitting on the scaffold. The scaffold is not meant for sitting. This is only meant to prevent people from falling off the scaffold. So it's not meant for you to sit there and stand there and start gisting. All right?
All right.
You can see also here, this is a source of fire on explosive material. Okay? An explosive to you. This could lead to a potential explosion. And when you look here as well, you can see that there's a huge, well, like I said, some of them might be exaggerated, but it's just meant for you to understand what the risk hazard is all about, hazard identification is all about. So you can see this guy here, right, lifting this huge equipment on just this while he's walking on the equipment. This could lead to crushing. It could fall and crush him under its weight. And you can see this as well. Okay, this is improper access equipment, just like the first one that we looked at. Is keeping just one leg here, and then he's working with his two hands on this grinding equipment. So it could fall from this height. All right, even though he's using other PPEs. Okay, even though he's using other PPEs, but this is unsafe action, unsafe act, and unsafe act. This as well. Okay, this as well. So that brings us to the, by the way, when you talk about hazard identification analysis, you could look at this image and identify a lot of things, right? There could be so much that you can identify from these images. And this has to do with, like I told you before, brainstorming. For some of them, you could obviously see that something is wrong. Okay, something's wrong. This man doesn't look stable. And then definitely you need to look for another approach. Okay, you need to look for another approach for him to lift this this good or this tool, or there should be another way to stack them. All right, in the design of the workplace or the design of the factory, you need to store your goods properly so that they can be accessed safely and brought down in a safe way. And some of these things you can also consult best practices. Okay, you can look at the industry, the various industries, and identify best practices. Okay. Same with this as well. You know, you have to make sure that the workplace is designed properly while you're taking into consideration the various hazards. If you know that you have to lift an equipment that is as heavy as this, then you have to make the provision. You have to make provisions. Okay. From the design of the workplace, or design of the tasks. Okay, you don't just come and do whatever you like or leave it to the discretion of the workers, because they might not have any knowledge or perception of the risk. And even look at this guy standing on it as well. This guy is standing on it. This guy is standing on it. All right, as well as this as well. Okay, so that brings us to the end of the lecture. Identification. All right, so thank you so much for listening. At this point, guys,